Here we have an example of solving radical functions. So remember that we need to isolate the radical using inverse operations as the first thing that we do. And then when we finish, remember that we need to substitute or plug in any solutions that we get. We might get one solution, we might get two solutions, and make sure that they are true in the original equation in order to accept them. Because when we have radical functions and we square both sides, which you'll see in a minute, it creates the possibility that we will have extraneous solutions, which we won't talk about a lot here, but just be aware that you do need to plug in at the end and make sure that your answers do indeed work in the original equation. Okay, so we'll isolate the radical. So we can think of this as being like 3z plus 5, 3 times something plus 5, because we need to know how to solve for that something, solve for that radical. So we should subtract 5 from both sides. So then we have 3 times radical x minus 2 equals 12. Then divide both sides by 3. So that now that isolated square root of x minus 2, radical x minus 2 equals 4. So that's isolate the radical is done, because now you just have the square root of x minus 2 isolated on one side of the equal sign. Once we're there, we need to square both sides, which you've heard Ms. Hogue say, when you square both sides, you cancel out the radical. So the radical is gone in the next step. So you see x minus 2, no radical on it because we canceled the radical, equals 4 to the second power is 16. Now it's pretty easy to isolate x, get x by itself, add this 2 to both sides of the equation, the inverse of negative 2. So we get x equals 18. So here we only got one solution. And now we need to make sure that that solution is true in the original equation by plugging it in. So that'll look something like 3 times the square root of, and then where that x was, we'll put 18. And we can think of this equal sign as being, is it equals, like with a question mark? So now we have to think about when we plug in 18, following order of operations, following PEMDAS or GEMDAS, what will we do next? So in this group under the radical, 18 minus 2 is 16. So here we have 16. Oh, we don't need that. Minus 2, we just need the plus 5. Like that. So now square root of 16 is 4. 3 in front, which is going to get multiplied by, and add 5, then equals 17. And we're asking ourselves, is that true? Does that equal 17? 3 times 4 is 12. Plus 5 equals 17. Yes, it does. And now we can say x equals 18 is a good solution here for this solving radical equations.